Hi everyone, so we will solve now this question. This question was asked from network theory. Okay, and this question belongs to the transient problem basically. But this question is slightly different, right? Whatever result we know, okay, for any general RC circuit, those results are not going to be applicable here, right? So please, I would like to comment here that you have to read the question very carefully, and if you know the differential equation, right, how to solve the differential equation and how to get those results, this question has been given to test your basic understanding of RC circuit, right, from the very scratch, you can say, right? So if you're going to apply your you know known equations that you know for voltage across the capacitor or current through the inductor, let's say RL circuit is given, then you might get wrong answer, right? So you have to solve this question, without any sort of shortcut, right? So the RC circuit shown below has a variable resistance. Okay, so this was one of the very good question that was asked in GATE 2019. So what we can expect here is in 2025 also we can expect the same question. Okay, the same question given by following expressions: RT is equal to R naught 1 minus T by capital T, and that is the range here is given as T is ranging from 0 to capital T, where R naught is 1 ohm, C is 1 ohm. So you see here they have given the value for R naught and C. 1 ohm means they want to make your life very simple. We are also given that T is equal to 3 R naught C, right? So you can just plug R naught C. So capital T value has T has a value 3 only, you can say. And the source voltage is Vs, that is 1 volt. Okay, that is also a constant volt. Okay. If the current at time t equal to 0 is 1 ampere, right? So they have given initial current IT, right? Okay. So why they have given this IT initial current? So that you can find the constant. Okay, because if you are going to solve the differential equation, so you will certainly encounter some constant in, okay, when you will derive the expression for current, right? Then current IT in ampere at time t equal to t by 2. It means they are asking at t equal to 3 by 2, that is 1.5. Okay, is what? And you have to round it off to two decimal places. So this question was very good question, and let us solve this question, right? So we can solve this question if you follow the conventional method or the actual method that you know to arrive at the correct result. Okay, so let's see start here. So what you can do here is, let's say this is a totally new question for us. We don't know this was asked in GATE 2019. You just expect that you got this question in 25, and you from where you have to start since you want to find this IT, right? So what you can do here is simply you can apply 1 kVL here, right, making sure that this switch is closed. Okay, you are applying just KVL. So by KVL you will get some equation, right, because you have to set up the differential equation. So you can apply 1 KVL, right? So around this loop, so you can start from minus Vs, then voltage across this, and then the voltage across this, right? So you can say by KVL. It is very simple, right? You have to notice that how Dheeraj sir is gonna solve. And if you're good at mathematics, what I always try to emphasize, okay, if you want to understand network theory, signal and system, control system, any subjects you pick up from any branch of engineering, mathematics plays an important role. The basic math, the basic science will never leave you. Okay, please keep this in mind. So by KVL you have to set up the differential equation. So let us write KVL. So minus Vs, okay, plus IT times RT, okay, plus confidently write down the equation. Okay, apply KVL. Okay, and the voltage across capacitor is nothing but 1 by c integration minus t minus infinity to t I tau d tau, okay, is equal to 0. Now what you can do here is you can take Vs that side. So Vs is going to be IT times RT, okay, plus 1 by c integration minus infinity to t I of tau d tau equal to 0, right? Now what you have to do here is, since RT is given, right, so you can just take RT and you plug here. Simply you plug RT, whatever RT is given, that is nothing but R naught. R naught is 1, to 1 minus t by, you know, capital T is nothing but 3, right? So you can just plug here in place of this t, plug 3. Okay, so this is RT. So you can now put in place of this IT, right? So this is nothing but Vs, and Vs is constant, so no problem. So IT times 1 minus t by 3 plus 1 by c integration minus infinity to t I tau d tau. It's a simple equation that we have written. Okay? Needless to write 0 here. Okay. Now, if you want to get the differential equations, what you have to do? You have to differentiate both the sides. So, what is the differentiation of constant, right? So, see, we are not using any sort of known result, okay, to be able to solve any RC circuit or RL circuit, okay. Slightly this question is different, okay. You have to remember that they have given variable resistance. So whenever variable resistance will be given, you have to set up the differential equation by yourself, and it's not a tough job. You can solve this question in 3 minutes. Your speed should be good, okay. So now you can differentiate both the sides, right? So what I'm trying to say here is differentiating both the side. So that is the reason Dheeraj sir always emphasize that please focus on mathematics. If you're ignoring mathematics, you are not going to get good rank, right? And if you get good rank also, it's fine. But in the life, you will be struggling. And mathematics pushes you go forward, take challenges, do better in your life. You will be always happy if you are good in mathematics, okay? So you can differentiate this guy. So differentiating this is nothing but, differentiation of constant is 0 is equal to, now you have to apply chain rule here, right? You can apply chain rule, okay, because there are two functions, okay, it and 1 minus t by 3. So you can apply chain rule. So we can plug just keep it as it is, and now it is going to be 1 by 3, right? Because the differentiation of 1 is 0 and this is minus 1 by 3. Then 1 minus t by 3. Now you can say I dash t, okay. I think this is clear. And integration, differentiation of integration is going to be as it is 1 by c, and this is it. Okay, just forget about that integral. You got this. I hope this makes sense. Now you can simplify this, okay, and you have to write, differential equation for it. Okay, so what we can do here is this is nothing but minus it by 3, and this can be written as 1 by c is 1, right? So you just forget about this c, right? This c is gonna be 1 only, right? So why we are thinking about it? So c is gonna be 1, so you can simply write this is nothing but it, okay, and this is plus 1 minus t by 3 I dash t, okay. Now what you can do here is you can say I dash t 1 minus t by 3, which is going to be equal to, you can take it common here, so it is going to be taken common, so 1 minus 1 by 3. Now you can simplify this, so this is it 2 by 3. I believe this is fine, right? And you can also simplify this side, so I dash t, that is dy by dt, this is nothing but t 3 minus t, okay, 3 minus t by 3. Now 3 gone both the side, you can just replace 3. So you can just cancel this 3 and this 3, okay. Now what you can do here is you can write this as I dash t, okay, this is I dash t is equal to 2it by 3 minus t. I think this is clear for all, okay. You can write this like this, okay. It's a very simple equation that you have got, right? Now what you can do here is you can apply variable separable method, right? So you can say that I dash t by it is equal to, you can write this as what you can do here is you can say that this is 2 by 3 minus t, okay. So now you can apply variable separable method, variable separable, okay. This is where the concept, the knowledge of differential equation demands, right? So if you're not good at differential equation, you can't solve this question. If you're going to apply your known results, okay, they are all going to be failing. Okay, so what you can do here is simple. You can just it will be nothing but ln it, right? Ln it is equal to, this is going to be 2 times of ln 3 minus t plus ln c, you can say some constant c. Okay, so this is going to be ln it, okay, which is going to be ln 3 minus t to square plus ln c, right? I think this is clear. Now what you can do, you can remove ln both sides. So this is it is equal to c times 3 minus t square, right? So what is this, guys? This is it is equal to c times, this is 9 plus t square minus 6t. Okay. Now what you can do here is at t equal to 0, they have mentioned that I of 0 is nothing but 1 ampere, right? In the question it is mentioned. So 1 equal to c, this is going to be 9. So from here you can say c is going to be 1 by 9. Okay. You got this constant. Okay. I believe this is fine. So what you can do here is, now you can just plug here. So it will be nothing but it is equal to 1 by 9, 9 plus t square minus 6t. Okay. Now what they want at t equal to t by 2, which is nothing but 3 by 2, which is 1.5. So what is this? I at 1.5 is going to be 1 by 9, 9 plus 1.5 square minus 6 into 1.5, which is 9 only. You just cancel this. Okay. So it is nothing but 1.5 into 1.5 upon 9. Okay, which is nothing but what? 0.25 ampere. So your answer for this question is going to be what? 0.25 ampere. Okay. So in the given paper in 2019, the range was from 0.23 to 0.27, and you have to answer this question up to 2 decimal places. Okay. So answer for this question is going to be 0.25 amperes. Okay. So this was not a difficult question. Yes, it takes times. Okay. It is going to take time, but in the exam pressure, you can solve easily this question by 3 minutes. Okay. I'm just explaining you, that's why we took little time, but this question can be done in 3 minutes. Okay. Maximum 4 minutes you can also give. Okay. Because not all questions are going to be consuming your 4 minutes or 5 minutes. Okay. So I hope you might have enjoyed. So sometimes in the gate examination, it happens that you have to solve question from scratch, and be ready for that. Be bold. Don't always rely on the shortcut. If you are relying on the shortcut, you're going to invest many years. Okay. So be ready to solve question from the scratch whenever it is required. Whenever you are in doubt, solve question from the scratch. Don't try to use shortcuts. Okay. So this question cannot be done from the known facts, like voltage across the capacitor is, okay, that is going to be vct equal to 1 minus e raised to power minus t by tau something kind of. Okay. You can't solve that. So I hope you might have enjoyed the solution. We will meet in the another session. Okay. So what is the takeaway? What is the learning from this video? The learning is we have to be ready in gate 2025 or upcoming gate. We have to be ready. We have to be rigid, bold. Okay. To take actions. Okay. Like we have to solve question from scratch sometimes. Okay. Using the basic concept. These are the basic concepts. So knowledge of differential equation. So that's why I urge to everyone, please solve mathematics on daily basis. Try to learn each and every concept of mathematics. If you are from electrical engineering, electronics and communication, instrumentation, data science and AI, computer science, mechanical engineering, civil engineering, irrespective of your branch, you should be good at mathematics as long as you are a kind of engineer, right? So thank you. We'll meet in the next session.